Okay, welcome to my class, and this chapter crude oil. Crude oil is a mixture of different length hydrocarbons, compounds containing carbon and hydrogen only. Okay, this crude oil is a mixture of different length hydrocarbon. There is a different hydrocarbons mixture is the crude oil, like petrol, alkene, methane, ethane, petrol, kerosene, diesel, refinery gases. This is the different length hydrocarbons. So crude oil is a mixture of different length hydrocarbons. Okay, these compounds contain carbon and hydrogen only. So crude oil is a mixture of hydrocarbons, compounds containing carbon and hydrogen only. There are lots of different hydrocarbons of various sizes in crude oil. Okay. This is crude oil. How crude oil is formed, I have discussed already. How the physical properties of hydrocarbon change with molecule size. So I have to show these things in figure. How the physical properties of hydrocarbon changes with molecule size. Like this is I was showing something. This is methane. This is methane. This is ethane. This is ethane. Okay, ethane. This is methane, ethane. This is propane. Like this is methane, ethane, propane, butane, pentane, hexane, octane, nonane, decane. This way change is increasing. This is a if this is small chain shorter molecules are like I give the which has more than 50 carbon in a chain or 20 carbon in a chain. They are longer chain hydrocarbons. So shorter molecules, have you understood? They are shorter molecules and more than like long chain. This is 3 carbon in a chain. If 12 carbon in a chain, 20 carbon in a chain, they are longer molecules. They are shorter molecules. So physical properties of hydrocarbons, what will be this? Look, these are shorter molecules. Physical properties of hydrocarbons. Okay, physical properties physical properties of hydrocarbons. Physical properties of hydrocarbon, shorter molecules and longer molecules. I am writing here shorter molecules. Shorter molecules. Okay, shorter molecules. Here the left hand side, shorter molecules. Shorter molecule. Okay, right hand side I will write longer molecule. Longer molecule. Longer molecules. Okay, shorter molecule like this shorter molecules. This carbon. This is methane, ethane. This is shorter molecule. Like I gave you one shorter molecule. This is ethane. I wrote here. This is the displayed formula. Longer chains, longer molecules like this. This is not shorter, longer, but I gave you example here. So this is longer molecule, shorter molecule. So here dot 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 dot. Okay, this is longer molecule or this is shorter molecules. So longer molecule and shorter molecules. Shorter molecules have low boiling point. They have low boiling point. You know this boiling point. Do you know boiling point? Arya Basharat. Boiling point, shorter molecule. Do you know boiling point? Boiling point is what is boiling point? Boiling point. Do you know what is boiling point? What is boiling point? Do you know? Boiling point is a temperature. At this temperature, liquid start boil. That temperature liquid start liquid to vapor step turn. The temperature this is called boiling point. So boiling point, shorter molecule lower boiling point. Lower boiling point. They have lower boiling point. I write BP this boiling point. Okay, shorter molecule lower boiling point. Longer molecule higher boiling point. Longer molecule higher boiling point. Okay, do you know why this shorter molecule lower boiling point? Can you say? Okay, a shorter molecule like how many carbon bond? 1 2 3 4 5 6 7. This 6 bond. So 6 bond to break 6 bond needs small energy. But longer energy, there are longer molecule. There are bond, lots of bond. So lots of to break these all bonds need a lot of energy. For these reasons, higher boiling points. They have more intermolecular force of attraction and lots of bonds contain longer molecules. For these regions, they have higher boiling points. This is small bonds contain, like only this molecule contain 1 2 3 4 5 6 7 7 bond contains bond chemical bonds. Okay, shorter molecules have low bonds, so needs small energy to break all this bond. Higher molecules have lots of bonds, so need a lot of energy. For this reason, higher boiling point. So shorter molecule, shorter hydrocarbons have lower boiling point. Higher hydrocarbon, longer is higher boiling points. Okay, their shorter molecules are flammable. Shorter molecules are flammable. If you methane gas, like you take some gas here, kerosene, like one gas, this is flammable. Shorter molecules are flammable. They are more flammable. They are also less flammable. These things longer, they are also flammable but less flammable. This more flammable. Like a natural gas, methane, more flammable. Flammable means how easily a substance catch fire. More flammable. They have less flammable. Less flammable. Okay. Less flame. Oh, sorry, this is playing wrong. Less flammable. Okay. So here, so again another properties is you know this longer chains methane gas it become easily gas. Become easily gas. Also gas. This is smaller chains molecules are easily become gas. So they are small shorter molecules are more volatile. Volatile means easily become gas. So they are more volatile. More volatile. Smaller chains are more volatile. They become easily gas. Easily become gas. Like this is a gas. They become easily gas. These things easily become gas. Here they not easily become gas. Okay, so they are how easily a liquid turn to gas. Volatile means how easily a liquid turns to a gas. So volatile. So small shorter molecules are more volatile. So they become easily gas. More volatile. Some are also some shorter hydrocarbon in a room temperature. They are always gas. You know, this methane gas is a gas. So they are more volatile, less volatile. Shorter, longer molecules are less volatile. Okay. Kerosene, like kerosene, shorter molecules. Kerosene, and here is a bitumen. Bitumen is used in the road construction. Alcatraz, like this bitumen. No, bitumen is for the road construction. Which one is Rani? Flow. Kerosene will flow. So longer, smaller chain molecules are Rani, their flow. Longer chain, they are longer molecules are sticky. They will not flow. Sticky, they flow. They are running. They will not flow. Flow, but not easily flow. They are sticky, or they are running. They are sticky. Sticky. Okay, they are sticky. Higher viscosity, they have lower viscosity. Okay, we have understood the physical properties of hydrocarbons. Okay, so here given these things, how the physical properties of hydrocarbon changes with molecule size. We have just seen how the physical properties of hydrocarbon changes with molecule size. These things, boiling point increases. The larger the molecule, the higher the boiling point. This is because larger molecules are attracted to each other more strongly than smaller one. More energy is needed to break these stronger intermolecular forces of attraction to produce the widely separated molecule in the gas. Okay, the liquid becomes less volatile. The bigger the hydrocarbon, the more slowly it evaporates at room temperature. This is again because the bigger molecules are more strongly attracted to their neighbors, so don't turn into gas easily. The liquid becomes more viscous and flow less easily. Liquids containing small hydrocarbon molecules are runny. Small liquids containing small hydrocarbons molecules are runny. those containing large molecules flow less easily because of the stronger forces of attraction between their molecules. The liquids become darker in color. Okay, if we flow shorter to higher, liquids become more darker. Shorter to longer, liquids becomes darker. Bigger hydrocarbon don't burn easily, smaller than as smaller ones. So bigger ones don't burn easily, but smaller burn easily. Separating crude oil. We know this crude oil is a mixture of hydrocarbon. How can we separate this mixture of hydrocarbon? Crude oil itself has no uses. So crude oil itself no uses. If we separate, it will be useful. So we must separate this one. Crude oil itself has no uses. It has to be separated into fraction before it can be used. This fraction are all mixture, but each contains narrow range of sizes of hydrocarbons with similar boiling points. We use fractional distillation to separate crude oil into fractions. This is carried out in an oil refinery. Okay, this is carried out in an oil refinery. Okay, we will separate crude oil by fractional distillation. This is carried out in oil refinery. Okay, how do the fraction means a range of boiling points like 20 to 30, 20 to 30, a range of boiling points. Some crude oil, these boiling points like 50 to 100, like 50 100 to 150, 150 to 250. This is the range of boiling points. This is a range of boiling point is called fraction. In a fraction we will separate oils by fraction wise. Like this temperature range is not given here. Like this is temperature range fraction. Like this is a fraction range. It is a LPG. LPG in a crude oil will enter here. Crude oil in a furnace, and in a furnace we will heat the crude oil. Okay, at the bottom high temperature. Okay, high temperatures at the to the top temperature is decreasing. So at the bottom, high temperatures hydrocarbons are at the bottom, and low boiling points hydrocarbons are at the top, because when we heat they become low boiling points hydrocarbons become gas and move to the top, and high boiling points they remain in the bottom, at the bottom. Then like this is the temperature range. This is greater than 350 or 350, or here's 350 fuel oil, and this is temperature range lubricating oil 250 to 350 lubricating oil, and diesel oil is 220 to 250, and kerosene is 150 to 240, and petrol temperature range is 70. LPG temperature range is minus less than 30 degrees Celsius. So we separate these things by fraction. This is a fraction. This fraction is residue. This is called bitumen. This fraction 350 fraction is called fuel oil. Lubricating oil, this fraction is called 250 to 350 lubricating oil. Okay, this fraction is diesel fraction is 220 to 250 degrees Celsius. kerosene is 150 to 240, petrol is 70 to 75 to 150. Okay, look, this is at the bottom. Okay, I have a question to you. This look fuel oil and petrol. Have you seen kerosene? Fuel oil and petrol, which one is shorter molecules and longer molecules? Okay, these are at the bottom. Yes, petrol, kerosene, LPG. Network is not best. Okay, look, this is given. These are small molecules. At the top, bottom, at the top, they are small molecules. Small molecules have low boiling point, very volatile, flow easily. Okay, small molecule. So low boiling point, very volatile, easily catch fire, easily become gas, flow easily, ignite easily, flammable, flow easily, runny, very volatile, low boiling points. Okay, small molecule. And high molecule, large molecules are high boiling point, not very volatile, does not flow easily, does not ignite easily, not flammable. Okay, does not not easily flammable. Okay, this is okay. How do in the how do we separate crude oil in a? At first, in the furnace at the bottom of the fractioning column, petrol is heated into vapor. At first we will heat it, then vapor. The vapor is pumped into huge fractioning column. We have seen there are different column here. Fractioning column. The column is cool at the top, but hot at the bottom. Hot vapor is rises up the column and begins to cool down. The smaller hydrocarbons are collected at the top of the fractionating column as gases. The bigger hydrocarbons are collected at the lower section of the fractioning column. Okay, we have in this fractioning column, bigger molecules are collected at the bottoms, and in the fractioning column, and the temperature range. In this temperature range, we collect this petrol, this fraction. Okay, so bigger hydrocarbons are collected at the lower fractionating column as a solid in maybe. Smaller hydrocarbons are collected. Okay, I'll arrange meeting after 10 minutes. The smaller hydrocarbons are collected at the top of the fractioning column as gases. Okay, uses of crude oil. At the top we see refinery gas. These are LPG, these are refinery gas, then petrol, kerosene, diesel, lubricating oil, fuel oil, residues, this is the bitumen. Okay, fuel oils for cars, aircraft. Okay, this is look given. I will give this question answer in the exam. Write down the uses of crude oil. Crude oil. Refinery gases. Refinery gas is for cooking purpose. It is used for the methane, ethane. These are propane, butane. They are refinery gases. Refinery are mixture of methane, ethane, propane, and butane, which can be separated into individual gases if required. Okay, these gases commonly used as LPG, liquefied petroleum gas, for domestic heating and cooking. Okay, refinery gases are mixture of methane, ethane, propane, and butane, which can be separated if needed. These gases are commonly used as LPG for domestic heating and cooking. Okay, next is petrol. This is also called gasolines. As with all other fractions, petrol is a mixture of hydrocarbons with similar boiling points. It is used in the car engine mainly, petrol car engine mainly. Then naphtha. Naphtha, it is used as a raw material for petrochemical industries. I don't know this clearly, this one. Naphtha. Kerosene. Kerosene is used as fuel for jet aircraft, domestic heating oil, as a paraffin for small heaters and lamp. Okay, kerosene. Now diesel oil. Diesel oil is used for buses, lorries, truck also maybe, or lorries, buses, some cars, railway engines where lines haven't been electrified. Some also cracked to make other organic chemicals produced. Okay, this here you can this used for bus, lorries, some cars and railway engines where line hasn't been electrified. Lubricating oil, it is used as oil for car engines and other machines. Fuel oil, it is used for ships, boilers, for industrial heatings. Paraffin wax, used to make candles, polish, wax paper, waterproofing and grease. Bitumen. Bitumen is used for the road construction. Bitumen is a thick black material which is used melted and mixed with rock chipping to make top surface of roads. Okay, evaluation. Okay, what is a crude oil? Okay, unmute everyone. What is crude oil? Mixture of hydrocarbons. Okay. Compounds containing carbon and nitrogen only. Okay, next is which one is more volatile between petrol and refinery gas? Which one is more volatile between petrol and refinery gas? Okay, at first you say which one is smaller molecules, petrol and refinery gas. Smaller molecules, refinery gas is smaller than petrol, so refinery gas is more volatile than petrol. Okay, next is say uses of crude oils. Say some uses of crude oils, like refinery gas, petrol, diesel, kerosene, bitumen. Bitumen, why do you use bitumen? Have you seen in a truck or bus writing D, give me, diesel, give me? This is used on the diesel is used for trucks, bus engine, diesel. And okay, this is the uses of refinery gas is used for domestic heating and cooking, and gasoline is used for why do gasoline is called petrol? Car fuels. These are used car fuel. Gasoline is used for car fuel, and kerosene is used jet fuel. Diesel is used truck fuels. Diesel. Okay. Okay. Thank you for joining class. Okay. Finish today's class.